Okay, so I'm just going to draw right now the x-axis with my 7 here, 4 here, -2 here, -3 here, -5 here. Okay. We're going to say the sign remains constant on each interval now list the intervals over here, and then we're going to write some stuff to the left. Okay, in each of these 6 intervals. Okay? Now we've already determined a big negative x. In other words, you have big negative x's in this interval, so just pick a big negative x, and you can reason out that q of x is negative on this interval, just the way you always reason out far left behavior. Okay? And here, big positive x implies q of x is positive in this interval. And in this interval, we have positive, right? So we can board over just a little more. Okay. I'm going to extend this a little bit, and I'm just going to put a big old negative here, indicating that from here back, this thing is negative, right? And maybe a little arrow saying from -5 on to -infinity. And from 7 to infinity, it's going to be positive. And from -2 to 4, it's going to be positive, right? Okay? Now, is it clear what I'm doing? So all we've got to do is figure out what happens on these 3 remaining intervals. So how are you going to figure out what happens in the interval from -5 to -3? I'll give you a hint. I would pick a number between -5 and -3. And see what the value is, see whether it's positive or negative, right? Okay? So, we'll put this down for a minute. A little more space. And bring it back because we're going to sketch the graph, okay? So, you usually want to choose an integer. You know, if you wanted to choose -3.4786 and figure it out, you could, but you don't want to do that. Okay? So choose -4. Cube of -4 equals negative 4 plus 5, negative 4 minus 4, negative 4 plus 2. Over negative 4 plus 3 times negative 4 minus 7. Now, we don't care about the numbers, we just care about their signs. What's the sign of negative 4 plus 5? It's either a plus or a minus.
Positive.
Positive, right? Negative 4 minus 4, positive or negative?
Negative.
Negative. You don't even have to do the arithmetic, you just gotta figure out which, if you got a positive and negative, which one's bigger, okay? Negative 4 plus 2, well, that's negative. And in the denominator, negative 4 plus 3 is negative, negative 4 minus 7 is negative. And all that becomes positive, right? Understand what I did? Okay, just make sure. Negative 4 plus 5, this is negative. Negative 4 minus 4, I'm sorry, it's positive. Negative 4 minus 4 is negative. Negative 4 plus 2 is negative. All these are negative except this one. It means you got 4 negatives and a positive gives you positive. I've just abbreviated that down here. So just make sure you see where these signs come from. I'm just writing the signs of these quantities here. Okay? These factors. Okay, so we can say that on the interval negative 5 to negative 3, the thing is positive, right? Okay. Now from negative 3 to negative 2, well, it's hard to pick an integer between negative 3 and negative. You can't use negative 3 or negative 2 because you're going to get 0. Okay? So it's hard to pick an integer, or you're going to get a couple of zeros, whatever. Okay, so let's go to the interval from 4 to 7. Now I'm just going to go to the signs, and I'm going to have to write down Q now. So we have it for reference. Okay, if X is between 4 and 7, and I'm just doing the signs of the factors. X plus 5 is positive. X minus 4 is what? Well, if X is 4, what's X minus 4? Give you a hint, it's 0. Right? You think X is 4, 4 minus 4 is 0. Okay? Now, if X gets a little bigger, because if you go in between 4 and 7, if you get just a little bigger than 4, what's going to happen?
It's positive.
It's going to be positive, right? Okay. Now, using similar reasoning, x plus 2 is positive, because in this interval, x is always positive, right? Don't have to do much thinking about that. X plus 3 is positive, doesn't take much thought. What about x minus 7? Well, if x is 7, this is 0, right? Now, if you go back toward 4, x is going to be a little less than 7, right? If x is a little less than 7, what can you say about x minus 7?
It's going to be negative.
It's going to be negative. Since the x value a little less than 7 makes x minus 7 negative. You don't really want to have to go to a calculator and say, okay, pick a number between 4 and 7, 5. Evaluate x minus 4. Evaluate each one of these for x equals 5, punch it in your calculator, get the number. You're not thinking about anything. I mean, you're thinking because you know you have to pick a number between here and here. That's a non-trivial thing, okay? If you're not thinking about the numbers and how they relate to these expressions, you're missing something important. But you could do that, okay? You could actually do that. Now, you wouldn't need a calculator, okay? A lot of people reach for them whether they need them or not. Now, the reason I did that on the interval 4 or 7 instead of choosing just like 5, in which case things would be pretty obvious, on the interval from -3 to -2, you're going to have to choose a fraction, okay? If you're going to choose a number, but you can reason that out just like you did this one. And I hadn't finished reasoning this one out, so let's back up a second. So we have positive, 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 negative, right? So all this implies positive, 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 or positive, negative, which is negative, right? Okay, so I'm going to write that out. I'm going to write okay, and for the interval from -5 to -3, I could write out this. Okay? Okay, well, on -3, -2, I can use the same reasoning I use here. Okay? If x is between -3 and -2, well, if I add 5 to any number in here, that's just like moving myself over 5 units. I'm going to move to the right of the origin. But it's pretty clear that any number between -3 and -2 added to 5 is going to make it positive, right? And any negative number added to -4 is going to make that negative, right? So I'm going to write down here, I'm going to write negative, positive, negative. What about x plus 2? If x is between -3 and -2, is x plus 2 positive or negative?
Negative.
It's negative. Because all these numbers are more negative than -2, right? Okay? So I'm going to say that one's negative. And then it's going to be over a positive. And x minus 7 is clearly going to be a negative. And that's going to make it negative. Okay? Make sense? Well, now I can come back to my original function. I don't break anything. And I can say, okay, well, I can take this information. I've got a negative here. I've got a positive here. I've got a negative here. I've got a positive here. Let's put it. I've got a negative here and a positive here. Put all that together. The graph is below the x-axis up to here, then it's above. And this is a 0, right? So it's going to come up here, something like this. And then it's going to come above the axis. It's going to have to stay above the axis all the way up to here, right? Now, you're not sure what's going to happen here, but let me just give you a plausibility argument. As the denominator approaches 0, what happens to the value? Well, it means as x approaches -3, this is going to approach 0, right? Which means this denominator is going to get really small. Numerator doesn't get really small. What happens if you divide something really small into something that isn't really small? How many times does a tiny thing go into something that isn't tiny? Lots. Which means you're going to get a big result. We've talked about this. Okay? Well, now we're going to be using it. So the graph is going to have to do this. It's going to approach this line as an asymptote, just like 1 over x or 1 over x squared approaches an asymptote at the y-axis, right? As a matter of fact, this is just, you could write this as 1 over x plus 3 multiplied by all the rest of this stuff, okay? 1 over x plus 3 is just the 1 over x shifted over 3 units to the left, right? That shifts your asymptote over to -3. And if you understand the functions, you understand what I just said, and I don't really have to say much more, but I do because most people don't totally understand everything. Anybody want to admit to not totally understanding everything? Yeah, but yeah, at this stage of the course, I expect that's the case with most people, right? Some people understand better than others. Some people understand what I just said, I would say. Okay, well, anyhow, now, from here to here, it's negative, right? Well, how's that going to happen? It's got to be negative from here to here. It's got to go through 2. It's got to go through the 0 at -2. Okay? Then it's got to go through the intercept. And it's got to go through this 0 here, right? Well, as soon as you get a little to the right of -3, well, x plus 3 is still tiny, isn't it? Okay? But now it's positive. Okay? But a lot of this other stuff is negative, and we know that the whole thing is negative here. That means you're on the other side of the asymptote, just like 1 over x, or just like 1 over x. This thing's going to do this. It'll come up here. At some point it'll peak before it comes back. It goes through the axis at -4. Okay? So when you have these things, you're typically going to have asymptotes. It's not hard to understand. I mean, it's a little hard to understand exactly why you have an asymptote, but if you think close to these things, the denominator is tiny, so you're going to get a big positive or a big negative result when you do your division. Okay? Then, well, we're going to approach another asymptote here. It's got to be negative between here and here. So it's going to come down here like this, and that's going to approach an asymptote. And that's going to be positive here. And this is a little tricky, and you don't have to totally understand this right now, but if you do, it's great. Well, your asymptote, again, you have an asymptote here. It's got to switch signs because it goes from negative to positive. So it goes all the way up here, but it's got to come around and do this sort of thing, so it comes down here and then it kind of goes off like this. Okay? Now, I don't expect everybody to be able to then, I don't expect to be able to give a bunch of these for homework and have people do a great job of graphing it. But I do expect I'll be able to give some of these and ask you to analyze the signs. Okay? And then go ahead and do an attempt at the graph. If you screwed up, okay, you're at least thinking, okay? And then we'll see what you thought that was wrong. Okay? So the assignment is going to be figure out all the signs and take a stab at doing the graph. Okay?